Hello and welcome to another J5 Productions. My name is Jonathan Veenstra and I will be going through with you an Arduino tutorial on working with servos. Servos are pretty easy to implement with Arduino. I've got a couple servos back here behind me. Well, a few actually. I have these two servos here, and these are just some basic servos I think I got with a college course. So I just keep these around to play with. And then I have this one, it's a parallax. I think it also came somehow with a college course program, but you can use either or. These two have a continuous turn, so they can be used as wheels or whatnot for such a bot or something of that nature, which uses servos as their wheels for turn and rotation because they're pretty easy to control. Now the standard servo is limited. It's about a 180 degrees limitation, so it can move back and forth from 0 to 180. And as always, we're going to be using the Arduino, or in my case a Cduino, in doing this project. So you're probably curious what's inside one of these servos. Well, there's not a whole lot, but what's there is pretty important. There's a motor, a potentiometer, an error detection circuit, as well as an H bridge, and a few gears. Servos come in many packages. They have some as small as a quarter, and I've seen some very large up to an industrial size use. They're pretty heavily used all over. The concept is pretty valid, though there is a debate on the internet as to what kind of modulation is used into controlling these servos. PWM, pulse width modulation, and PPM, which is pulse position modulation. Now, I'm not trying to say which one is right, which one is wrong. It's always been known to me, pulse width modulation, and it looks pretty much like it, but it has its differences. So we'll just leave it with whatever signaling is used here. There's also some debate in the programming threads as to how you call up a servo in your program. Some try and use the analog write, and that's probably not the best method. There are some comment postings out there describing why this doesn't work or why it shouldn't work, but basically it's not putting out the pulse width modulation required to control a servo properly. Now in today's Arduino tutorial, we're going to be using the servo.h library. And a library is basically a bunch of commands that are already pre-written for you, and you can just call up the functions that are part of this library. So it makes it real simple to code, and we'll see that here in the next 4 demonstrations I'm going to go over with you. The first, we're going to use a limited servo, the standard servo, and we're going to program the Arduino to move it back and forth between 180, and then we're going to use that servo again and tie it to a potentiometer, and we're going to use a potentiometer to control the servo. Then we're going to move up to doing dual servos. So then we're going to take the 2 servos, these are the continuous rotation, and we're going to tie them to the Arduino board and control both of them using programming. And then in part 4 we're going to use these 2 continuous servos again, but then we're going to also tie in a potentiometer, and with the potentiometer we will be able to control the speed, forward, reverse, and stop, and otherwise throttle to control the Arduino and make it move. Maybe it just might serve some ideas in you guys on how to start making your own robot, because this is a great start to getting your robot moving. Get some locomotion. When using large servos or multiple servos, you want to make sure to double check the power requirements of that one servo or that combination of servos, because with too much power draw for the servos, you can overdrive the circuit of the Arduino or the computer you might have it attached to. So you want to make sure to double check how much power you're going to need and set up an auxiliary power if that's going to be required to power the moving servos or other devices attached to the Arduino. Servos give us great positional control. With using servos, we can precisely position a part where we need it to go. Especially on robots, they're very helpful for rotating pieces, or you put two of them together, you make a nice pan tilt for a head operation. And you throw a few of them together and you end up with like Johnny 5 back here, who's, I believe he's stacked with 13 servos, so lots of programming going on there. So with no further ado, let's get to our robot projects. Welcome to part 1 of the Arduino Servo tutorial. And on this first project we're going to be working on here, we're going to be adding a single servo. This will be a limited servo. So we'll open our Arduino IDE to get started. Okay, now I already have these sketches pre-made, so I'm just going to open the sketches and we'll talk through the sketches on what's involved. So the first one, we'll start with a sweep. And we'll get rid of this other blank sketch. And we'll open this up and expand upon it so we can see what's going on here. Get all our notes in there. Alright, so this first program is pretty short. So we got to include our servo.h in our headers, so make sure you do pound include servo.h. And then we start with class. Then we start an object of servo titled hobby servo. Then we create a variable int pos for the position, and we'll be storing our position variable there. Then we go into our setup, and first off we have to set up what pin our hobby probe is going to be on. So we do hobby probe attach, and this dot attach is a function that's called to the object hobby servo and telling it that it will now be sending commands to pin 11. So we'll start with our loop, and we take, and for position 180, so this is setting the POS variable, a reading of 180, and if 180 is less than or equal to 1, it will move on. It will continue to loop here this program, and each time subtracting 1. And basically this is going to rotate the servo from 180 down to 0 degrees. So each time this thing loops through, it writes to the hobby servo. So this again is another function of the servo class, and sending it to the hobby servo, telling it the position it's at each time it does move. And this happens really fast. We have a delay in here of 15 milliseconds, so it's running through it pretty quick. This delay is what's going to limit that move, so it can actually respond quick enough to your input. But we're going to delay 15 milliseconds before moving on, so each time this runs it delays 15 milliseconds. And once this gets down to 1, then it's going to move on, and for position 0, so it's going to set the position to 0, and as long as the position is less than 180, it's going to increment the position by 1. So it's going to count from 0 up to 180. And again, it's going to write to hobby servo the position that it's in, and with a little delay, so it's going to move it one direction from 180 to 0, and then it's going to move it back from 0 to 180. So let's get our hardware all set up, and let's try this program out and see what it does. Bring in our servo, and I already have pins set up here for the high and low power. So we got 5 volts and the ground coming over to the terminals here on our breadboard. So all we then need to do is plug these wires that I've extended from the connection of the servo. And the red and black wires on this one are your high and low. So you want your 5 volts running to your red, your ground running on your negative, and then the white wire is your signal wire. So we will, and on this one, from our program, we know our signal wire attaches to pin 11. So we'll just stretch it a little bit over here and place it into pin 11. So we'll flash it with our code. So we first compile our sketch, verify that there are no errors. And once we are compiled, then we shoot the code. Alright, there goes the code. And there it goes. We can see the rotation. It's moving in 180 at a time. And it's just moving back and forth, just as our code states. So, really quick, just to show you what happens here, using the same circuit with the 2 servos. This circuit worked pretty good for the limited position servos, but if we were to take this same program and run it with a using a continuous turn, we will see the servo acts a little bit differently. So you see the continuous turn makes about 2 rotations before it turns around again. And this is basically because the code is telling it to do something different. What the code is actually telling the servo to do in this program, how the continuous rotation servo responds to it, is by looking at the position number or the position value more as a direction and speed of which to go. So it's either going to go forward or reverse. So when it's at 180, it's full power and moving forward. When it's at 0, it's full power and moving backwards. And at 90, it is not moving and it is stopped. So as this varies through, it's just changing its speed until it gets to 90, then it changes its direction, and then it speeds up going the other way, and then it moves into the other program taking over and just swings back and forth. So now we'll move on to the potentiometer. Bring this servo on back. Alright, make sure we find our pin 11. Yep, there it is. So we're back up and running. We want to kind of shut this guy off. So now we're going to change this code up a little bit, and this time we're going to add a potentiometer into our circuit, and then we'll be able to control the servo ourselves. We start here with, as always, the pound include servo.h. This is our header file for our servo library. We need to include that to be able to use any of the servo functions. So we start with the servo object, and we create servo object hobby servo. And then we create a port for the potentiometer, so we create this position pot and set it to analog pin 1. And then we create a variable, just POS for position, for storing position after the read of the analog pin. Our hardware setup, so we want to call to hobby servo object and tell it to attach pin 11 as it's the pin that it will be sending all the commands to. So then we go through our loop. So we got a simple loop here that just takes the position, and we do an analog read, and that's just a function of Arduino that's there that we can call into the hardware to read the port to find out what the value is. And then we're going to take that and store it to the POS. And then we're going to use the map function that we've seen yesterday, but this we're going to map the POS, what the current POS is, and we're going to give it a range from 0 to 1023 for the variable potentiometer, and then a 0 to 177 range for the servo. So now we should be able to range the potentiometer from 0 to 1023, and the servo should move from 0 to 179. So as it reads and moves and goes through this continuous loop, it's going to read, it's going to map, and then it's going to send to the hobby servo object that we created and tell it to write this position out. So this will be sent to the output, and then delay again 15 milliseconds, and it just continues to run through and update. So seeing the program, now let's see how the hardware looks. Okay, on the hardware we don't need to change anything. In fact, it can all stay the same. We just need to add to it. So what we're going to add is, first we want to get us some power terminals here. So we'll set us up here with there's a ground. There's our high. And we then want to put our potentiometer in there. And then off our variable wiper, inside the potentiometer, there's one connection that picks off of the resistor value. We want to send that one to port 1. Alright, so now that we're hooked up, let's send our code over to the Arduino. So we upload our code. Code is now uploading. And code is completely uploaded. So let's connect our pin back up here. Okay, now our potentiometer here, we can rotate it. And we see as we rotate the potentiometer. So now as we rotate the potentiometer, we see that the servo moves along too. And since in the last video I showed you the operation of a continuous rotation servo on this circuit, I'll show you it again here too. So we will disconnect this circuit and remove this servo, and we'll bring back that continuous rotation. Okay, and we can see with this where the potentiometer is at, it continuously runs. But we can find a place right in the middle somewhere where it stops. This is the 90 position where it would stop moving. And then if we rotate it the other direction, it goes full speed in one direction, turning it back. Now it's going to slow down, and it'll speed up in the other direction. So you can use this on a continuous drive circuit by just turning it backwards from the 0 to 180 to just going across to 90 and changing the forward and reverse values. Very simple. I hope that gives you a lot of great ideas for your projects. And we're going to move on to part 3 of this Arduino tutorial on servos and show you how to use 2 servos. In the third part of this tutorial, we're going to look at controlling 2 servos. So we'll start by loading our program and finding out what we need to connect and where. So we go to Open, and this time we will take Servo Duo. And so here we see the pound include, which we have been using. I created a servo object of Hobby Servo 1 and Hobby Servo 2. And then we create a variable rate. And then we set up our hardware. So we take Servo 1, attach it to pin 11, Servo 2, and attach it to pin 10. And then we go into our loop. And for the loop, as long as the rate, we set the rate equal to 180. As long as the rate is greater than or equal to 0, the rate will go down by 1. And then it's going to send out to the object instance Hobby Servo 1 the rate, and then also send the rate minus 180 to go in a reverse direction, because ideally this would work on a robot of sort with 2 wheels or meant to run in the opposite direction for some reason. And then it's going to delay 15 seconds, and then it's going to go again from 180 through 90 to 0, and then stop, delay 15 seconds, and then go again. So basically this is doing the same thing as before. The sweeper, it's just sweeping from one position to the next, but this is doing it with continuous rotation servos. So we will hook one of these guys up here. Alright, and we are connecting one of them to pin 10. And we connect our other servo and connect it to pin 11. So we have both of our servos connected, so now we can just download our script down onto okay, our script is now downloading. And we see now both servos are being controlled. So it's rotating them in opposite directions. So you can make something that rolls around, maybe drive. But these could easily be with a couple sensors. You can navigate around objects and tell which way to turn based on sensor inputs, similar to a potentiometer. So speaking of potentiometers, let's go to the next code and see how we're going to put a potentiometer in to control both of these. So let's go and load up our servo dual with potentiometer program. So a dual pot, that's the sketch we're working with. And for dual pot, we're looking at same servo.h being included. We have our servo, hobby servo 1 and hobby servo 2 objects created. And we create a throttle potentiometer, throttle pot is what I called it. And we're going to put it off of pin 1, same place it was before. And for this one we are going to use 2 continuous rotation servos. That's the way this sketch was designed to run. And then we create variables for storing the servo's velocities is throttle 1 and throttle 2. So now we go to setup and we set up our hardware. So we send hobby servo 1, we attach to pin 11, hobby servo 2, we attach to pin 10. We then go into our loop where we call throttle 1 and do an analog read of the throttle potentiometer, find out what the throttle potentiometer is, and put that value in the throttle 1. Then I call up throttle 2 for a good reason here, because I'm doing my map and I want to map to throttle 1. So we're going to map the controls again. So we're going to map throttle 1. And I've adjusted this little bit to basically have a good 0 so you stop at the same time. So this is where you're going to be able to do your adjustments in your mapping to a lot of controls to act the same at the same point, such as stop at the same time. When I first did this, one would stop, the other one wouldn't. You couldn't get a position where both of them would stop at the same time. To reverse them, I just changed the number from 179 to 0, and we scale the position and range. Servo full forward is at 80, stopped is at 90, and full reverse is 0. So we want to make sure to map to throttle 2 first, because if we would have mapped to throttle 1, then it would make the change and then send it back to throttle 1. And then it would change throttle 2 based off of 1, and we don't want that. So what we want to do is convert throttle 2 first, because the input value will be the same, reading from the same pot, and set 2, and then we'll go and set 1, and then with both controls mapped, we send the 2 values out to Hobby Servo 1 and Hobby Servo 2, and they should go the same way. So now let's go set up our hardware and check this baby out. So we'll set up our pickoff for the ground and another pickoff here for our 5 volts. And then we're again going to run a wire from our pin 1 over to our pin cut, our wiper pin. And then we again set up our servos to go to pin 11 and pin 10. And with those set up, we are ready to program. That's the old program still running. We're uploading the sketch for the potentiometer now. Alright, here comes the code. Alright, appears our code has taken. So now we vary the potentiometer. And you can see as we rotate it, they turn. We can find our happy medium and go the other way. So basically you're not too far from creating a small robot. So if you wanted to you can tie those two together and you nearly got a robot going here with your potentiometer. Get it moving. But we can make it stop. Find that sweet spot. And we're all set. And that's how easy it is to get a servo set up on an Arduino and get you right on your way to building a robot. Thank you for watching the Arduino Servo tutorial. We're always excited to hear your feedback, so please leave some comments below and let us know what you are doing with your servos. If you need any more ideas like this one on how to integrate the servo with your hardware, check out this book, Arduino Cookbook. This book has codes in it for probably anything you would want to do with your circuit. In pieces, of course. You have to put it all together. But it's a great start to getting you on a step to building that really nice robot. Arduino rocks!